Solving systems of linear equations using substitution, lesson 10 notes. Before I do example 7, I would like you to flip to the very back of your notes where you have a blank page, pause your video, and write that down. Okay, so real quick, this is only going to take a couple seconds to look at this. You know, if you look at each equation that is on this page, every single one of them has a coefficient other than positive 1. You know, this coefficient is -3, this coefficient is 9, this one is 6, and this is 2, and so forth. So which one, when every variable term has a coefficient, which one is easiest to solve for? Well, you got to look to see how many steps it would take. This here would take 2 steps. You'd have to get rid of the 6 and then divide by the 9. Both of these would take 2 steps because the x and y are on the same side and both have a coefficient. The only one step would be this step here, and that is because that's multiplication. The opposite would be to divide. Now, you don't always want to do this. You want to make sure whatever you're dividing by divides into these numbers. So is 9 divisible by -3? Yes. Is -6 divided by -3? Yes. So I'm going to solve both of these by dividing by -3. So I can cancel that, and I would get y equals -3x plus 2. So again, if you don't know what to solve for, try to look to see what is one step. If you're going to divide, make sure that it divides out evenly. Because if it doesn't divide out evenly, then you might want to do the 2-step to solve. All right, so let's look at this one. All right, x and y are on the same side. They both have a coefficient. It's going to take 2 steps for each of those. The y down here is with the constant term, so it's going to take 2 steps. You'd have to get rid of the constant term, then divide. This is the only one that's going to be 1 step, but you want to make sure that it divides into the other numbers. Is 6 divisible by 2? Yes. Is 8 divisible by 2? Yes. So I'm going to solve for this x by dividing both sides by 2. That would cancel, and you would get x equals 3y plus 4. All right. So I just want to show you that because there is a problem like that on the worksheet and the test. So I wanted to show you how to do that. All right, let's go up to example 7 now. All right, so I've got 10x plus 2y equals 6, 5x plus y equals 2. Which variable is the easiest one to solve for? Well, this y has a positive 1 coefficient, so that's what we're going to solve for. Pause your video, write down, solve for bottom y, plugged into top y. All right, so I'm going to start by subtracting 5x from both sides. I want to isolate the y. That would cancel. So y equals, bring down -5x, bring down +2. Okay, and now this, I solved for the bottom y, so that is going to substitute into the top y. I solved for the bottom y, so it will substitute in for the top y. And that would look like this. 10x plus 2 is the same, but the y is replaced with -5x plus 2. All right, now we solve our 2-step equation. I'm going to start with the distributive property. Now, notice I didn't circle the 2 this time. You can if you want. The only reason I circled it in the example up above is because that 2 was a -2. This one's a +2. You can still circle it if you want to, but it's a positive, so I don't need to worry about that sign. All right, bring down the 10x. 2 times -5, x would be -10x. 2 times 2 is 4, and that equals 6. Combine like terms. Look at that. We've got 10x minus 10x. Those are opposites. What happens with opposites? They cancel. In other words, my x term goes away. I no longer have an x term. It cancels out. So the only thing I have left is I bring down this 4 and I bring down the 6. But does 4 equal 6? No, it does not. Therefore, if the numbers don't equal one another, this is one of those special types of problems, and it is a no solution answer. So if your variable terms cancel out and the remaining constant terms are not equal to one another, it is a no solution problem. So the variable terms cancel out and the constant terms do not equal one another, it's a no solution problem. No solution problems are much quicker than the other ones. Pause your video, make sure you have all of that written down. Okay, let's do number 8. Number 8, we've got negative 9x minus 3y equals negative 6, and 3x plus y equals 2. So again, this bottom y has a positive 1 coefficient. That's what I'm going to solve for. So pause your video, write that down. All right, to solve for the bottom y, I need to get rid of the x term. So I'm going to subtract 3x from both sides. So y equals, bring down the negative 3x, bring down the positive 2. And I solved for the bottom y. Since I solved for the bottom y, it will get substituted in to the top y. Try that again. Solve for the bottom y, substitute it in for the top y. That would look like this. Negative 9x minus 3 would stay the same, but the y is replaced with negative 3x plus 2. All right, let's start with the distributive property. I am going to circle this again because that's a negative there. So I'm going to take negative 3 times negative 3x and negative 3 times 2. All right, so I'm going to bring down that negative 9x. Negative 3 times negative 3x would be positive 9x. Negative 3 times positive 2 is negative 6, and that equals negative 6. Combine like terms. Well, I've got negative 9x and a positive 9x, so just like the example up above, my variable terms here are going to cancel out. So 9x, or negative 9x plus 9x, the x's cancel. So I bring down what's left. On the left side, I've got a negative 6, and on the right side, I get a negative 6. So again, this is one of those special types of problems. But in this case, when the variable terms canceled, the constant terms are equal to one another. So I want you to look up here. Here, the 4 does not equal 6. That's why it was no solution. But down here, negative 6 does equal negative 6, making this infinitely many solutions. Pause your video and make sure you have everything written down. Okay, so the last step now. The last step I want to do is I want to check 7 and 8 using the graphing calculator. So check number 7. Well, if you look at the two lines graphed there, they are parallel lines. Parallel lines have no solution. Parallel lines have no solution. So number 7 is correct. So now let's check number 8. All right, I don't know if you can notice there. All right, let me get rid of the pink one. There's the purple line. Let me put the pink back. Get rid of the pink, put the pink back. So they are the same line. In other words, it is coincident lines, meaning that coincident lines is infinitely many solutions. So we are correct. All right, if you have any questions on examples 7 and 8, please let me know.